الرحيم الرحمن علم القرآن خلق الإنسان علمه البيان الشمس والقمر بحسبان والنجم والشجر يسجدان والسماء رفعها ووضع الميزان ألا تطغوا في الميزان وأقيموا الوزن بالقسط ولا تخسروا الميزان والأرض وضعها للأنام فيها فاكهة والنخل ذات الأكمام والحب ذو العصف والريحان فبأي آلاء ربكما تكذبان أعوذ بالله من الشيطان الرجيم
Comstech and PABIC in order to raise awareness about ongoing activities regarding modern technologies of agri-biotechnology in Pakistan and regarding awareness of how the common people can be well informed by the science via science communication. With this, I would like to introduce our first speaker, Dr. Rodora Altimata. She is the Director, International Services for the Acquisition of Agri-Biotech Applications South Asia Center, Director, Global Knowledge Center on Crop Biotechnology, Member Steering Committee, Department of Agriculture Biotech Program, Member Technical Committee for Basic and Applied Research. She holds her PhD in Botany from Indiana, USA, and postdoctoral fellowship from Germany. She obtained her BS and MSc degree from the University of Philippines, Los Baños, and leads the development and publications of ISAAA Annual Global Status of Commercialization Biotech Crops. So I welcome Dr. Rodora. Rodora, can you hear me? Ola, can you hear me? Okay. Give me 5 minutes.
यहाँ से तो म्यूट नहीं है।
स्वाइन सर इनको को होस्ट बनाइए.
There. Hi,
Yeah,
I can hear you now. Can you turn on my camera, please? There, thank you so much. Good morning, everyone. I'm going to share my slides, and I'm happy to be here at Comstech to participate in communication of science. So here I'm going to present my, share my slide. And slideshow, okay. Yeah. So I'm from the International Service for the Acquisition of Agri-Biotech Applications, and my talk will be communicating the global trends of biotech GM crop adoption for 2020 for 2019. So today I'm going to discuss with you two types of talks. The first would be biotech crops, and the second is how we are communicating it. Do you hear me well? Do you see my slides? I hope so. So the problem that we are having now is we have high global population. The climate change is heavily affecting food production. We have 20% likelihood of severe food insecurity and undernutrition. And with more than 820 million still hungry, it is very difficult to achieve the SDG 2 goal of zero hunger by 2030. This will require biotech applications. That's why I am going to discuss with you what's going on with biotech crops. And then later on, I'll tell you how ISAAA is communicating science across the world. So my talk would revolve around biotech crop adoption in 2019, biotech crops and traits, and the future prospects. So from 1996 to 2019, we have this much production of biotech crops, about 190.4 million hectares of biotech crops were grown by 29 countries by 17 million farmers. And it has been a very good opportunity for farmers to use new varieties that have improved traits. That's why from 1996 to 2019, we have recorded, ISA has recorded 190.4 million hectares of biotech crops planted in industrialized countries and in developing countries. So you will see here that developing countries has planted 55.5% of the global area compared to the industrial countries which had planted 84.7 million hectares. And crop adoption in 2019 has also increased up to 190.4 million hectares, which I said earlier. But this was a decline of 1.3 million hectares. And I'll tell you the reason why there was a little bit of a decrease. There was also a 112-fold increase from 1996. That means we have biotechnology is regarded as the fastest technology for food and agriculture. And from 1996 to up to now, there has been an accumulated 2.7 billion hectares of biotech crop area planted all over the world. So here we see the 29 countries which planted biotech crops, and continent-wise, we can see that the US and Canada planted 44.1% of the global area biotech crops, followed by, this is now the Latin America side, which had also similar to the US, which is 44.1 million percent also. And then we have Asia and Oceania at 10.23%, followed by Africa and Europe. So in Africa, we have three additional countries, namely Malawi, Ethiopia, and Nigeria. Now, looking at the map, we can see that there is still a lot of places, a lot of countries that have to adopt biotech crops at the moment. So currently, there were 10 Latin American countries, 9 Asia Pacific, 2 North American, 2 EU, and 6 African countries, which is a very good example that developing countries are getting to benefit from biotech crops as they adopt biotech crops in their own countries. So the top 5 countries that planted biotech crops include the US, Brazil with their adoption rates, Argentina at close to 100% adoption, Canada at 90%, and India at 94%. But in these 5 countries, you will note that 3 are developing countries and 2 were developed countries. So there were 2 double-digit increases in biotech GM crop area. So Vietnam really increased by 86% by planting biotech maize. They have, and also the Philippines, which had increased 39% of increase from 2018, and Colombia at 15% increase, which now composes maize and cotton. So in terms of the different crops, you will notice that in this one, you will see that um, there are more crops planted in North America, such as maize, soybean, cotton, canola, sugar beets, alfalfa, papaya, squash, potato, and apples. And in Latin America, these are the crops planted. And Asia and the Pacific, where we are, we have cotton, maize, canola, eggplant, sugarcane, and safflower. And these are the total biotech crops area planted in the different regions of the world. So still, we can see that North America and Latin America lead, followed by Asia and the Pacific, 19.5, African continent, and the European Union. Now, in 2019, we have seen that biotech soybean is still the dominating biotech crop all over the world, followed by maize, biotech maize, cotton, and canola. You can see that there are fluctuations. There were fluctuations in the global area. These are because of the price, the global price, the supply and demand, and of course the climate that affects the planting during the planting season. Now, globally, here is how we look at the adoption of biotech crops. 79% of the global cotton is already biotech. 74% is for soybeans, maize, 31%. So we still have a long way to go to get into very close to 79%, just like cotton. And then canola at 27%. Um, this sometimes change. Last year, it was soybean, which was very high, followed by cotton. Now it's cotton, which is the most in demand by the crop in the world. In our area, in the Asia Pacific, these are the countries that have planted. Okay, this is led by China, followed by, no, this is led by India, I'm sorry, with BT cotton, followed by China, Pakistan, and then the rest of the Asian countries, which we have the Philippines, Australia, Bangladesh, Indonesia was the newest addition. And then there were countries which just imported by the crops. They are not planting, that they have been importing by the crops for food, feed, and processing. So we have Japan, Malaysia, New Zealand, Singapore, South Korea, Taiwan, China, Thailand, and Turkey. So in all, there were 17 biotech crop adopting countries in our region, Asia and the Pacific. So in terms of traits, we can see that the trait which has the stock traits, you see here the orange colored one, the stock traits which have varieties containing the herbicide tolerance and insect resistance is now slowly dominating by the crops area. And you see here that by 2019, it has surpassed the herbicide tolerance trait one. So the stock trait is now being planted at 85.1 million hectares compared to the other ones. So these again are the different countries which planted by the crops with their by the crop area and the crops that were planted in these countries. So what are we looking at in terms of biotech food, food and feed crops? So here we can see that in the US, we have this is the innate potato, which is the non-browning potato, which is now being planted in the US at 2,265 hectares. And Canada has also been planting it. Arctic non-browning apples are already planted in the US at 265 hectares, and it's going to be planted in Canada. And also, this is already being commercialized in Canada, and this in 2020, it was commercialized in the US. We have also, again, our a very important crop, the eggplant, the BT eggplant, which has been planted in Bangladesh since 2015. And you can see that it's already in the Philippines, there has been an application for food, feed, and processing. And hopefully we will see this also in India. And then in Canada and the US, the Harv Extra low lignin alfalfa has been planted in increasing hectarage. And in Argentina, it is being field trialed already in Argentina, and hopefully it'll be planted very soon. Uh, in um, in Brazil, we have, oh, sorry. In Brazil, we have 18,000 hectares of insect resistant sugarcane and planted. And then we have also drought tolerant sugarcane in government owned farm in Indonesia. And then 3,500 hectares of high oleic safflower in R&D in Australia. And in Costa Rica, we have been seeing pink pineapple since 3 years ago. And the area planted to this was 115 hectares in Costa Rica. Most of these are for export because some countries uh, are starting to commercialize pink pineapple, which has high anthocyanin and very, very sweet. Um, Now we'll see. Hold on, I cannot remove this. Okay. Um, in the Are you seeing my slide properly? Okay. So here is now the status of approved events for biotech crops used in food, feed processing, and cultivation. And we have here at the ISAAA website this GM approval database, which shows 72 countries have issued 4,485 regulatory approvals for 32 GM crops since 1992. And the USA has the most approvals of 539. Maize followed, had the most approved events in 26 countries. And herbicide tolerant maize event NK603 has the most approvals in 29 countries. So here we have um, the, okay, hold on a minute. Okay, so here are now the crops which are going to be in the pipeline, meaning they are now coming very soon to us. So here we have non-browning romaine lettuce, Colorado beetle-resistant potato, herbicide-tolerant wheat, and nutrient use efficient, water use efficient, and salt-tolerant rice. And also, in 2019, we have these new approvals, drought tolerant cotton in the US, low gossipal cotton in the US also, most of them in the US, multi-insect resistance and herbicide tolerant maize in Brazil and Argentina, and then as the same traits for cotton, and very importantly, in Paraguay, Brazil, and Argentina, drought tolerant and herbicide tolerant soybeans have been given approvals for biotech cultivation. Okay, so let's move on to the cultivation contribution of biotech crops to food security, sustainability, and climate change. Here, these are the data from Graham Brooks published in 2020, and it showed us that biotech crops contributed to crop productivity by $225 billion. This is the farm income gain from 1996 to 2018. The same way, it also provided a better environment. We have 776 million kilograms of global reduction at the same time. We have conserved biodiversity, meaning we have saved 231 million hectares of land from plowing and cultivation because this amount of crops, this crop productivity would need 231 million hectares to be planted. But due to biotech crops, we don't need to touch 231 million hectares to produce this amount of crops. It also reduced carbon dioxide emission by 15.3, which is equivalent to removing 15.3 million cars off the road for 1 year. So that's about 23 billion kilograms carbon dioxide. And most importantly, Biotic crops help alleviate poverty and hunger. And you see here, Biotic crops uplifted the lives of 17 million farmers and their families, totaling 65 million people. So biotech crops have been contributing to all of this, to food security, sustainability, and climate change, most especially now when we are at pandemic. We know that most of the biotech crops that are already planted in the field in 29 countries are contributing to help us feed the world. So biotech crops ensures continuous economic benefits of biotech crops, and we have to make sure to have diligence and forward-looking regulatory steps based on science. Please move this window. Why is this making? Um, okay, I cannot remove the black. Okay, okay, yeah. So let me go back there. So biotech crops can help address challenges identified by FAO. So the challenges are still here. We still have problems on population growth, urbanization and aging, climate change, transboundary pests and diseases, and nutrition and health, food losses and waste. So in here, we can see that if we continue on being diligent and forward looking, regulatory steps are being implemented in many countries. And if we critically look at the benefits instead of the risks, environmental productivity with environmental conservation and sustainability will come. And we need to always consider millions of hungry and impoverished population. So now let me move on to the next part of my presentation, and this is communicating science the ISA way. If you have time, please, I invite you to come and look at our website, the ISA website, isa.org, and you will see there a lot of important materials that you can use in your biotechnology information and dissemination activities. So we have here, you can see here that our website has been visited by a lot of people from different parts of the world, and it has been accessed many times, especially our GM approval database and many of our materials, which are targeted to different stakeholders. So let me walk you through the ISA website. So first, I'd like to introduce again the global status report. So it's already there. It's a database of global adoption and distribution. We have country situation, benefits, and future of biotech crops, which I have just explained to you in detail. We also have many feedback from people who have read our biotech report, and they said that it is the most reliable source of data on GM cultivation. It is a one-stop place for authoritative details of countrywide biotech status. The report is extremely useful for academic research, and it is being used for many publications and presentations. So the ISA briefs, which have been published in the last 23 years, and the one which we published last year in 2020 is the 24th series of the report. So I'd like to invite you to visit our website. And for the brief 54, which is the data for 2018, we have obtained 85.8 or point 0.9 billion media impressions, a million impressions. And so we have from coming from news articles, social media mentions. We have languages used about 10, countries reached 45. Well, it was being sold, and we have sold several copies. And for this year, the Brief 55 for 2019 It's made available at the website, but it's only the executive summary, which is um, given away for free. So you can download the executive summary for free, as well as these infographics on do you know where biotech crops are grown? Proceeds from the sales of the ISA briefs and all of the materials will be used to fund the development and distribution of the next brief, which is brief 56. So I'd like to invite you to come and check on the materials that are available at our website. So we can give you the PDF copies for this. And so we have the PowerPoint slides, the infographics on the brief. This one is the top 5 biotech crops all over the world. Now, I'd like to mention that the biotechnology information centers have a big role in our ISA operations, in our activities. So, in Pakistan, at PABIC, in Karachi or Pakistan Biotechnology Information Centers have been very useful or have been a part in the brief 55 preparations or in the brief preparations. So these countries have been providing us data which we collate and we put together to put together the ISA briefs. We also make launches. So this is one way where we can make everybody know what is the content of the brief. So this is another way of communicating the brief or the contents of the brief. And for this year, we have launched the ISA brief in African region in Kenya, Arabic region in Jordan, Europe in the Netherlands, Latin America in Argentina, and on March 11, we're going to have the launch in Australia in La Trobe University. So these are new partners with us. And we had also one launch in the Philippines. Now, today I'm doing this and happily with Pakistan, PABIC Karachi here in Islamabad. And then we will also have more upcoming launches in the different parts of Southeast Asia. So, so this is one way of communicating the contents of the brief through the launch. Another one is Dr. Graham Brooks, who is um, an economist based in the UK. He has been collaborating with ISA in producing the global economic impact of GM crops. So last year, we also conducted, through the help of the Biotechnology Information Centers, several of the webinars we conducted. So we had one in Manila, one in Beijing, China, New Delhi, India, Bangkok, Thailand, and Lahore, Pakistan, Bogor, Indonesia, and we'll have one in Hanoi this March 2021. So this is one of so the biotechnology information centers are very instrumental in producing this webinar series. We also have the Asian short course on agri-biotechnology, biosafety regulations, and communication. And in this way, we are teaching young regulators, young scientists, and young communicators on the different aspects of biotechnology. So the science, regulation, and how we can communicate. So we have done the third installment of this, ISA Southeast Asia Center and the Malaysia Biotech Information Center. We collaborate on this, and we also have collaborations from the BIC or Biotechnology Information Centers. And I'd like to also introduce to you our newsletter, the Crop Biotech Update, which comes to your email. So you can subscribe at the ISA website so that you can receive this e-newsletter, which we publish every Wednesday. It is important to note that the contents of the Crop Biotech Update is not anymore only on crops. It also covers different organisms, animals, livestock, microorganisms, and how biotechnology is being used to improve these organisms for human purposes, for our purposes, for the humankind. Also, we have the GM approval database, which is also one of our very important and very much looked at part of the website where we record the approvals of different GM crop events. So you may see our website to look at this. So we also use the social media. Currently, we have Science and She, and you know that March is Women's Month. We have featured different women who are very outstanding in their field of specialization, biotechnology, the sciences, or in science communication. And then we have also Science Speaks, which is a blog published by ISAAA. You can look at this at the ISAAA website or through the crop biotech updates. And finally, I'd like to thank you for your attention, and you may contact us at knowledge.center at isa.org for more information, or if you want to ask questions to me, to us, and you can visit our website at isa.org. So with that, thank you very much.
Thank you so much, Ola, for your very informative lecture. I would like to ask one or two questions, take one or two questions from the audience. Okay. Ola, can we scroll down the comments?
Yeah, I am, yes, I am now looking at the chats.
Yeah.
There is no question yet. There is one. Um, okay, I'm going up now, and okay, I don't see any questions. They're just asking if we can send the PowerPoint to them.
Okay.
Uh, the one question is, oh, nice presentation, they said. So I think there's no question as yet. Do we have any question from the audience there?
Yes, there is a question from the audience.
Okay.
Hi, my name is Eddie Mehmet. I'm from the science journalist. Uh, I have just one question. I have seen the progress of biotech crops for a long time, at least 25 years or so. Still, we have some conspiracy theories around the globe using social media and various websites. So, what ISA is doing to offer remedies or questions raised by such conspiracy theorists online and offline as well? Thank you. I would like to hear from you.
Can you, the question is again what it is? What is the,
Uh,
I didn't get the question.
Salim is asking that what about the ISA initiatives to address the various conspiracy theories regarding biotech crops.
Concerns on biotech crops?
Yeah.
Okay. What are the concerns again?
Salim sir, could you kindly repeat your question?
For example, we most of the time conspiracy theorists.
Salim sir थोड़ा करीब कर लो.
Now, can you hear me now? Okay. Uh, Most of the time, the conspiracy theorists say that the conspiracy theorists say that the those who are using biotech crops or growing biotech crops are the big companies, and they just want to capture the agricultural wealth of the world uh, for their own benefits, and allow only those who will pass those benefits to such corporations. This is
Okay.
one
If you could,
example that we have time and again. But there are a lot of conspiracy theories there. So my question is whether ISA has a plan or an initiative to address such conspiracy theories, concerns, or questions raised by such people who call them skeptics, uh, so that a common man, a person like me, uh, who can also see the other side of the story, because whenever we see such uh, conspiracy theories, a common man, a common person gets literally confused, and that hampers the progress of biotech crops in our country. Thank you.
Okay. Thank you so much, sir. I got your question now. Well, you may notice that in the beginning, we only have four major crops, and these were developed by multinational companies. And they were the first ones who started it. They were the first one who researched, developed it. And since the products of these multinational companies are very, very useful for our food and agriculture, especially we have corn, soybean, cotton, and canola. Those are our food, feed, and oil sources. That's why the use of these materials were very much needed. So in the beginning, that was the trend. But when I presented to you different crops which were developed by the public sector, now we have a lot of crops developed by the public sector, not anymore the multinational companies. So we're looking at BT eggplants, although it has been developed by a multinational company, it is now being uh, provided as a humanitarian act by these multinational companies to different countries such as Bangladesh and the Philippines for production of eggplant for food. So they do not get any more monetary return from that. I mean, these multinational companies. We also have a lot of materials developed by, for example, in Australia, a lot of their products are developed by universities, not the multinational companies. We also have uh, this alfalfa developed by also by public sector. So the thing is, if we are going to provide incentives or support our scientists to develop our own products, then we can succeed. We don't need to rely on multinational companies, and we can also target crops which are also for our own use. And we can see that it is already developing. It's also coming. So we're no longer limiting our crops to those four major crops. I know that there are still a lot of skeptics, but come to think of it, we benefited. You can see the benefits that I have presented to you, the benefits that were delivered to us in the last 23 years were enormous. Even if they were developed by these companies, the global community were beneficiaries in terms of food and sustainability, environmental sustainability. We don't need to use anymore as much hazardous chemicals. We can also think about the IPM, the integrated pest management, which these multinational companies also tell us what to do so that we're not going to use anymore as much chemicals. So it's an integration of collaboration between the public and the partner, the public and the private sector also, so that our biotech crops can be availed and all our the global community can benefit from it. Thank you so much for the question. There are a lot of questions, so maybe I'll start looking at them. One question is from does ISA have any collaboration with Bangladesh? Our We used to have Bangladesh Biotech Information Center, but due to the change in our person there got promoted, so we don't have any more person there. But we have been contacting with the universities and of course Bari, and we have uh, our global coordinator Mahalakshmi Arujanan is consultant of the food for Food the Future in Bangladesh. And so for the BT eggplant project, it's we are also in it. What about the biosafety concerns of biotech crops that approved? Well, I have presented to you the benefits. Now, the biosafety, all of the biotech crops which are available in the market have passed through biosafety risk assessments, the environmental and the food safety assessment. And it will not be commercialized unless it has passed through all this biosafety assessment, which follows international standards. So for food safety, we're following the Codex Alimentarius, and for environmental safety, it depends on the genes that were integrated into the crops or introduced into the crops, and all of those are assessed on their effects on the organisms in the soil, in horizontal transfer of the gene to its neighboring crops, crop stand, and all other environmental biosafety risk assessments. Thank you. Now, yes, so I have just mentioned the debate according the safety of these crops. So may I also emphasize that biotech crops have been commercialized for more than 24 years, and there has never been any recorded lethal effect to people and to the livestock or to the Okay, sorry, I was cut off. Should I continue?
Yes, Ola, please.
Okay. Let me also again, yeah, I look again at the chat box. So there has not been any recorded lethal effects. Okay, where am I now? Does ISA document used in agri laws and policy making in any country? If no, what scope does it have? Actually, ISA is helping countries develop their capacities for biosafety. We have partnerships with governments and also with um, some funding agencies, especially the US Department of Agriculture. If they see that a country needs help in developing their own capacities, they contact ISA and we help them in their capacity building. Also, we have projects in the Philippines and other Southeast Asian countries funded by other funding agencies. I cannot tell you what those are. But anyway, so ISA do not have documents on that, but we help. We invite speakers, we put together a program. So currently, but currently we have a project in Myanmar, and it has been going on since 2018. But because of the what's happening now, so we have to stop a bit. We also helped Vietnam in their development of their biosafety framework. We're still helping the Philippines also, and currently we have projects and targeting animal biotechnology, not crops only. We're moving into other types of regulation, not only in crops but also in animals. Um, Okay, any link with you, collaboration? Okay, so you can contact us. You can look at the ISA website. You can provide your contact details. And if you want to collaborate with ISA, we are going to start working on our new ISA, which is a biotrust consortium. This will cover different organisms with biotechnology. So it can cover biotechnology in crops, animals, microbes, fermentation, um, some on enzymes, and all that. So please contact us at the isa.org. There is a contact us icon there. You can email us there. And what else? Okay, there are questions on how can I work with you. You can just email us at the contact us icon in the ISA website. Now, I'd like to give you a few takeaways before I end my open forum. Actually, ISAAA has been in this space of biotechnology since 1996 or since 1992. And we have started collaborating with people from the very beginning. And so now we are moving into another one, Biotrust Consortium, as I said, and we are welcoming collaborators. So also, we have the ISA website will also be improved to cover all these new developments. And we partner. Actually, we have new partners now. As I said, we have new partners in the Arabic world, in Europe, in Latin America, in Africa, we are strengthening, and in Australia, we're also moving in. So we hope that Pakistan would be continuously with us. We have Pakistan Biotechnology Information Centers here in Karachi, and then we have one also in Lahore. So I'd like to invite you all to see our website and be a subscriber of our Craft Biotech update. You can just put in your email address in the ISA website there, and every Wednesday you will receive the Craft Biotech update. Currently, we have close to 25,000 subscribers. So any news that we send out in the newsletter is received by this large number of people. We are also big on in social media, and you can also like our ISA page over there. So can we do collaboration of institute? Yes, just contact us and we can talk. We are now moving into many different fields with different collaborators. So contact us and we will let you know. My email address is raldemita at isaa.org. Thank you. Thank you for your attention.
Thank you so much, Ola, for such an informative presentation and detailed answers of the queries. My privilege and honor to introduce my very dear teacher and distinguished national professor, Professor Dr. Muhammad Iqbal Chaudhary, currently working as Coordinator General Comstech and Director, Pakistan Biotechnology Information Center, International Center for Chemical and Biological Sciences. And he will talk about the popular science writing, bridging the gap between science and society. Please welcome Dr. Chaudhary.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله وبركاته. My colleague my colleagues, Professor Dr. Khurshid Hasnan, Professor Dr. Samar Yusuf, we have many renowned journalists, Murtaza Noor Sahab, Aleem Ahmed Sahab of Global Science, and a lot of distinguished faculty members and scholars. Assalamu alaikum wa rahmatullahi wa barakatuh. You see, when Mr. Aleem has asked this question of even with literally 40 years of agriculture biotechnology, there are still questions. And there are questions of extremely serious nature, which really makes you worry, the questions relevant to multinational companies taking over agriculture sector. There are questions about health concerns. There are questions about GM jumping into the human gene, and a lot more. That actually reflects that somewhere and somehow the biotechnologists who work so extremely hard to develop these wonderful crops, which today are feeding 7.8 billion people, uh, which was not possible without the introduction of genetic engineering, somehow and somewhere have actually failed grossly in communicating science in a proper way. And that is the reflective of the fact that you would still find lots of people speaking and writing about GM crops with completely non-scientific or pseudo-scientific perspective. And you would find lots of claims made against genetically modified crops completely based on hearsay and baseless grounds with no scientific evidence. And that is the basis why it is important that every ISAAA launch, which we do that in Pakistan, we always try to do that along with the seminar in which we discuss how effectively science can be communicated. And it become even more important because never in the history of the world we have seen miscommunication and misinformation affecting people as we have seen in year 2020, a remarkable year of real-time science and a real-time misinformation, you know. So while scientists were busy in making vaccines and diagnostics, there were a lot of people who were busy in cooking fake news and misinformation. That is the dilemma of 2020, and that actually tells us that how important it is to effectively bridge science with society in a very effective way. So my presentation is going to be very general, and I'm going to talk to you about why, despite the fact that science has contributed so much in the well-being that we cannot even imagine a world today without science, there are still people who don't simply understand science or who are against this science. And that is not only for biotechnology, it is true for everything, literally. You know, when it comes to vaccination, you would really find now this vaccine is rolled out, and you would find lots of people who would resist this vaccination, as they have done in case of polio. There are lots of people who doesn't really believe on climate change. Yeah, there are lots of people who doesn't believe that that man has ever landed on moon. You know, so there are a lot more misinformation than one could think of. And I'm going to cover a bit more why and how science has contributed and what is the basic motive of science in bringing lots of these breakthroughs, discoveries, and how to connect science with the society. So it's going to be a very general presentation. And I want to start with a question. You know, I want to ask you a question. What if you have born in 1940? A time when my mother was born and my father was about 15 years old. So this was the time when if you had born during that time, the average life was only 49 years. Think of it. Most of us, not you, but many of us, some of us who are sitting in the audience have well surpassed that average life, and perhaps at the token of about 13, 14, 15, 16 years, we are living longer than the average life. And your chances of dying with simple cholera and bubonic plague were about 30%. So even if you have lived from child mortality, survived child mortality, the chances of dying with simple infection was really very, very high. And at least once, or maybe twice, you had suffered a basic food shortage, a complete famine. That you have seen in Bengal famine, you have seen in Indian 1936 famine. It actually happened in 1944 also during the Second World War. Hunger was widespread. A lot of people died because of the lack of food. Even a minor surgery may have killed people, you know, because of the infection which surgeries was resulting. So what has happened was that science responded, and science always responds to human challenges and crises. Green Revolution fed the hungry, so there is no major famine In the world today, uh, global life expectancy has increased to certain places at about 88 or something. The average life expectancy in the world is 76 years now. So you live 76 years, and perhaps in some years, many of you would perhaps pass over 100 years. So people who were born in last 10 years have every likely chance of celebrating their 100-year birthday with health and happiness. Antibiotics and vaccines saving the lives of millions of people today. And miracle happened that within 11 months, over 200 vaccine candidates against COVID-19 were developed. So this is the miracle of science. And within that $5 vaccine package, you can have children protected for against many fatal diseases, lifelong protection. And that has happened because of science. And there are many turning points in the human history, launching of industrial revolution of 18th century, transformation of transport system in 19th century. Now we fly supersonic, almost supersonic plane. And within 20 hours, you can have a complete circle of the world, protecting many countries from the hunger in 20th century and rapid advances in electronic information. So you see internet, IoT, AI, all of that are major breakthroughs. These are the landmark turning point in the history of humanity. And for at least past 2 centuries, application of science and technology have been the critical factor in human development. Now, how the world look like today, even in the post-COVID period, if there is any post-COVID period. You are connected to everyone in the globe, 7.8 billion people individually without any problem. You can connect to them with very chances of an error, each individual anywhere in the world. We are ready to land on Mars. Mars is a very crowded place today. That 3 or at least 4 of these Mars missions are circulating around this lonely planet long time ago, which was in solitary uh, condition. Now it is a party place because lots of missions all around circling Mars, and they are seriously thinking of having colonies at the Mars also. Biotechnology is growing organs from your own tissues. This is happening. Journey towards literally eternity. Whatever fails in the body, you can grow them by using regenerative medicine and synthetic biology, producing bacteria, which can produce literally everything. So you can grow cells in cell factories. You can produce pharmaceutical pigments, vaccines, polymers, literally everything. Viro cell, which is the basis of many of these vaccines, is green green monkey's kidney cell, epithelial cell, in which most of these Chinese and Sputnik vaccines are based on. So a lot of development are taking place, but there are still lots of challenges. Of course, we have seen challenges of unprecedented nature. Global warming, we have this global warming. Our planet is melting. Emerging resistance in bacteria and viruses. So we see microorganisms winning the war. Emerging viral diseases, Ebola or COVID-19, food security is still a major issue. And that is the reason why it remains extremely important to keep working in the field of agriculture. Comstech has a program on food security, and we work with our partners to ensure that we keep motivating different institutions to keep working in the field of food security. Over 3 billion above the age of 60 years, so we have this huge population, aging population, for which we need to have a new class of medicines. And of course, energy crisis, so powering the life is a major issue also. Digital divide is a major challenge for the world, and loss of diversity. We are losing our evolutionary partners every day. And there are in fact lots of challenges which science has to meet. And there are disciplines which have actually emerged to meet those challenges. Biotechnology for food, growing plants in air and floating farms and seawater. It is now possible that salinity can be overcome with almost the same level of sea water. You can still grow plants because genetically modified plants which are salt tolerant are now available commercially. 3D printing is of organ, rejecting the organ rejections. Gene editing is now with CRISPR-Cas designing smart life forms. You can now design your own bacteria and viruses. It is literally possible to design the primitive form of life. Synthetic bacteria that will design to manufacture fuels, medicines, and food. Nanotechnology is changing the whole paradigm of the world. So there are a lot of things happening, and I'll just go through some of the breakthroughs which has happened in the last 20 years. Biotechnology is providing the building blocks for sustainable future, agriculture, medicine, industries, environment, in every aspect of it. Agri-biotechnology is one aspect of it also. And our dear friend, Dr. Ola has already mentioned about how agriculture biotechnology is contributing towards improving the livelihood of people in the world and feeding the hungry. And of course, lots of miracles are happening. Medical doctors are even thinking of transplanting human head. This has happened actually, but they are improving the surgical technologies to a level where people can live with a new head donated by somebody else. 6.2 billion mobile telephones today. So 6.2 billion people can be connected by mobile telephony. Wi-Fi for everyone on the planet is very much in this sight. And communication between the brain and machine, so-called interfacing of brain and machine, is one of the major development which is looming, which is taking place very quickly. And technology is actually strengthening people in a major way. So there is exoskeleton, a number of augmented strength. If there is a problem with hearing, you can have augmented hearing. If there is a problem in muscular weakening with MS patients, you can have your exoskeleton helping you in a major way. So there are lots of development taking place in science. And of course, age of new automobiles and transportation domain is changing for good. So driverless car, smart planes, 100% solarized aircrafts, they're all very much available in sight. And artificial intelligence is changing. You know, the fast track development of AI during 2020 has helped us in handling the crisis, the health crisis, because AI helped in tracing, tracking, and treating people of COVID-19. Watson is much smarter. Now Watson of IBM is considered to be at least 1,000,000 times more smarter than human brain. So this is a lot happening all around, an Internet of Things. You know, infrastructure, information, devices, machines, and everything is now connected in a very coherent way. There's completely seamless connectivity between human hands, human brain, machines, and the interfacing of that level where you can really connect with everything. So, and this is what I really very close to my heart, because I'm a chemist, you know, and I have studied throughout my life this periodic table. And this periodic table has properties. You know, every element is given a property, a mass number, atomic number, a physical state, boiling point, melting point. But it's changing. You know, if you convert that element into nanoform, it may look very different. So the whole periodic table has to be redefined. Everything has to be redefined. Their physical properties, their toxicology, their chemical properties, everything need to be redefined. So chemistry is in the process of redefinition. Redefining chemistry is what nanotechnology is creating a new niche. And beyond the frontiers, so there are mega projects, you know. Beyond the frontiers, in terms of this particle physics, where people are trying to understand how this subatomic particle behave. So this is the frontiers at a nano level, femto level, and then beyond the frontiers when we go to beyond the planet Earth, when you go to somewhere in the solar system and beyond. So a lot more is happening in the science. And an unprecedented development took place in the field of science during COVID-19. Never in the history of the world, science has played such a phenomenal role as we have seen in year 2020. It's a completely mind-boggling, is a remarkable year where real-time science was introduced. People were going to the laboratory, discovering something out, coming out and tweeting it. This conventional science of sending your research paper, which goes through a different layers of peer review, has really gone beyond. Now everything was happening in a real time. Real time science was available in this year 2020. And this is what I want to tell you. Only science has responded. Where global diplomacy has failed, where economic diplomacy has failed, where international cooperation have grossly failed, science is the only thing which responded. And this is the miracle of science. So somewhere in Wuhan, when a mysterious cluster of flu-like virus, flu-like symptoms were discovered in November, within 6 weeks of the discovery of this mysterious disease, Chinese and Australian scientists published the complete genome in completely public domain. They have not patented or AIPR or anything like this. It was made available to the people within 6 weeks. And within few hours of the publication of this first genome, people were already up to developing of diagnostic kits, and people were already up to developing vaccines. In few hours, it happened in real time. Within genome publicly available, Germans and Chinese have started producing these diagnostic kits, which were made available to everyone on the face of the earth, whoever wanted to purchase within few months. So by the end of February, this PCR-based diagnostic kits were available, as compared to HIV, which took about 4 years for them to develop a credible test for HIV/AIDS. Biology of the virus was done in real time. Its mechanism of infection, its structure at an atomic level, its capacity to spread through non-symptomatic individual, its surface and airborne viability, its capacity to interface with ACE2 inhibitors in body, how it infect. The spike proteins of every kind were all deciphered in 750 paper, 7,000 research papers which were published by April 2020. So this is the kind of science which actually took place in last year. This enable us to make policies. This mask regime of social distancing and closing down and locking down, and all of them were actually based on surface cleaning. It was all based on the science which were deciphered within few months. An entire molecular structure of the virus, including the viral genome changes which is taking place today, are real-time available. There are so far 200,000 genomes are reported. 200,000. Every change which is taking place in this virus is reported within few hours of the sample sequencing. So drugs were repurposed, many drugs were repurposed, 350 clinical trials were conducted within 6 months, ventilators were made for the whole world, AI and IT were used for disease surveillance, tracing and tracking. November 2020, within 10 months of the genome discovery, 90 vaccines were forerunners. 90 vaccines, according to WHO, 90 vaccines were in phase 3 clinical trial, including completely new technology of messenger RNA-based vaccines, which enable you to produce vaccines within weeks now, because you already know the template of this virus. And when in 91-year-old British lady got received the first vaccine, since then there are many countries where 50% population over has already been vaccinated. So this is what science has done. But think of it, but if there was no science, what has happened? These are the predictions available simulation models. Uh, Based on the basic principle of natural herd immunity, 70% of the people has to have infection and they have to recover in order to have a natural herd immunity. Spread has to be continued for years in order to achieve this number. Over 5 million people had to be infected. 5 billion people. 100 million had to die with the most conservative estimates of mortality. 1.5 billion people had to live with long-lasting post-infection morbidities. This is the cost of not doing science. Think of it. Have we communicated this to anyone? I mean, perhaps this is new for many of us also, but this is what the projections are. This is what, if science has not responded, we had to have pay the cost of not doing science to this. This need to be communicated. But in fact is that science is dividing. For instance, even today, we want to buy a vaccine in this country. We have money. We have set aside $165 million to buy vaccines. Vaccine is not available anywhere because it is overbooked by 50 richest countries of the world. And it is then extremely important that we bridge the gap, we start talking to society, and science and society start working together in this very interesting communication linkages, so-called nexus, which my colleague, Mr. Aleem, would actually discuss after me. So this is what we need to do. Why it is important? Because fruit of human ingenuity, this science, this wonderful outcome of excellent mind working together in a very focused approach has to reach to the people. It is important that these are communicated. Science must become basis of common culture, because when science is a culture, then myths are not there and misconceptions are not there. So science has to impregnate into the cultural behavior of people. And that can only happen when people understand science at the core. Not as a scientist, but science in a way that they understand the rationality behind the science and the advantage which science offers. Science is now everyone's business, and COVID-19 has shown that to everyone. You cannot really let it happen by some so-called scientists working in their laboratories. They have to work closely with the society because society finance them. And I give you two examples. If Mendel was not able to communicate the law of inheritance, science of genetics have been 40 years behind. If Fleming was not failed to communicate the discovery of antibiotics, a lot more people have actually died. So science has responded to human. But there are lots of myths. You would still find, you just Google. I invite you to Google and write that man never landed on moon. You would find thousands, if not millions, of posts where you would find all kinds of Photoshop tricks. And there are still people, 38% of the American citizen, the country who sent a man on the moon, doesn't really believe that any man has ever landed on the moon also. So this is the failure of science communication. Then GM food is evil. Ola was trying to tell that safety has been well established. There is not a single credible scientific study which shows that GMOs really cause anything serious except some allergies. Even then, there are 76% of the countries, only 29%, 29 countries have commercial cultivation of biotap crop. 76 countries, including European countries, have never accepted GM crop as a mainstream agriculture crop. So it is really a major problem, even in the most educated countries also. And environment, there are lots of people don't believe that global warming is taking place. You see two poles shrinking, especially the North Pole shrinking. You see large chunks of glaciers melting, and they don't still believe that global warming is real. They think it is just a myth. So there are lots of things actually happening in climate change. Is for them is just a fake news. And COVID-19, never ever we have seen how fake news kill people. Where president of the most powerful country of the world says that why don't you just drink bleach, because that would help you to get rid of COVID-19 vaccines, or take hydroxychloroquine without any, and that is just a flu-like thing also, and who have seen the virus, and then it is engineered by so-called Chinese, or that it is just because of the result of 5G or 6G or 7G, or poor Bill Gates, who become the victim of this fake news. So a lot of things this actually happen, and closer to home, this is what we have seen in our country. Salam Qawmi hero, पानी से गाड़ी चल सकती है ना, तो ये भी होता रहा है, and our politicians were encouraging all this whole thing. So unfortunately, there are lots of, and this is, we are the victim. Only 3 countries in the world, Pakistan, Afghanistan, and Nigeria, all happen to be member states of OIC. 3 countries of the world who still have polio, because there are people who doesn't really believe on it. And not only believe, they are so violent that I don't know how many of our healthcare workers have lost their life because of this ignorance. Think of it. हम उन्हें सेलिब्रेट नहीं करते, हम दुनिया जहान की बातें करते हैं, हमने कभी उनकी बातें नहीं की जो गलियों में मर गए या मर गए, जिन्होंने बच्चों को बचाने के लिए अपनी जिंदगियां दे दी. It is just all, unfortunately, the failure of scientists. So we unfortunately live in a world which is so divided in terms of understanding, and that scientists have failed. I would accept as a professional scientist that we have failed to communicate science in a very objective manner. Pakistan science communication is at the losing front. And my colleague journalists would actually tell you that there used to be science pages in many of the newspapers. You don't find them anymore. You would find them, you would find how to make Mughlai dishes and all that, and other things. But science page has vanished. There is no science page in many of the popular newspapers. Number of science magazines have decreased. Less than 0.1% time of electronic media is dedicated for science and technology. You hardly find any news channel, any private channel discussing science and technology in Pakistan. No one. They don't want to talk about science. Internet is the major contributing factor of spreading the misinformation. Everything is so easy to forward myth and fake news everywhere. And anti-science lobby is now leading. Pseudoscientists and anti-science lobby is on the winning front. And my fear is that even if we are able to roll out vaccine, if we are able to purchase vaccine, there would be large number of people who would not accept it because they already have this myth in their brain that vaccine is not good for them, and or somehow, they will not be able to be as productive as they wish to. So It was a very unfortunate situation. And this is the reason why such debates are extremely important. My presentation is the preamble of what you would hear from Ali Ahmed Sahab, and really feel that it is an area in which we all have to work. Journalists have to understand science, and scientists have to understand how to write science objectively. You know, there was a time when somebody told me, if you wish to communicate science, you need to make sure to society, you need to make sure that you should be able to differentiate between hype and hope. You don't create a hype. You create a hope, but you don't create an hype. You don't really want to be claiming something which you will not be able to deliver. Science is always very cautious. Now you have to have another front, misinformation. You need to fight against misinformation. So science communication has now multiple fronts to fight, and this is the time we all have to work with the society, with the scientists, and with the press together, and that is the science for. So when science can be communicated by scientists, it is very effective. Equally important is that when journalists understand science and communicate them in a very objective and effective manner. You know, one of the key reasons why we established Pakistan Biotechnology Information Center some 16 years ago in this very building was that we wanted to give information about biotechnology in a very objective manner. We wanted to tell them this is the science, you know, this is how we perceive biotechnology. This is how the world perceives science, biotechnology. These are the benefits of biotechnology, and these are the research which has been conducted. This is the downside, this is the upside. You need to make sure that safety is established before you introduce any crop in your country. And this is the reason why informations were critically important. So I don't really take much of your time. I just wanted to tell you that we all have to be engaged with media. We need to educate public. We need to go out of this jargon. You know, scientists speak a language which nobody understands. They have developed their own vocabulary, which is unfortunately so difficult that society cannot understand. Therefore, we need to translate our English into an English which people understand, our Urdu into an Urdu which society understand. And we should be willing and ready to answer questions. This is very important. And gain support for future science. We all need to understand that there is no science unless there is a support for science, and the support for science comes from society. Society is the constituency from where science draws its strength. Science can only flourish in a country where society is favorable and supportive. Otherwise, there is no other. Science is what separates us from the Stone Age. Just think where we would be without science. This is something which we need to communicate. And developing countries differ from developed countries not only because they have less wealth and capital, but because they have less knowledge. And this is what I really like the most. It is science alone that can solve the problems of hunger and poverty, of insanitation and illiteracy, of superstition and deadening customs and tradition, of vast resources running to waste, or a rich country inhabited by starving people. We indeed could afford to ignore science today. At every turn, we have to seek its aid. The future belongs to science and those who make friends with science. Thank you very much. Thank you. Any question, I would be happy to respond to. Yes, sir.
Assalamu alaikum. I'm Ijaz from Qaid-e-Azam University. I'm a research scholar. I'm here to ask a question that how much effective the launching of these information centers and some sort of like research centers here in Pakistan. And because PABIC is a popular center, and how much effective it could be for young researchers, because there is a great huge challenge for young researchers about the funding of the research, and sometimes it's really tensible for conducting the research due to the shortage of equipments, the materials that are not available in Pakistan. So my next question is how much the communication between science, technology, and the universities and the industries is being developed here in Pakistan. Uh, so because it is about public communication between science and public, so industry must be related here.
Thank you very much. You see, I just wanted to, I mean, related to that, I just wanted to give you a background. You know, all that development about COVID-19 in 2020, which I mentioned about development of diagnostic kits or ventilators or vaccines. You know where it happened, where all this happened. It all these development happened to those places which were already doing it. You know, diagnostics were developed by people who were in the business of diagnostics. Vaccines were developed in the places where vaccines were developed before. Capacity building is extremely important. This country wasn't able to do anything. You know, we have no diagnostics, no vaccine. We are 100% reliant on not a single place in the country which can produce vaccine. And this is where I link to your question. Investment in science and technology infrastructure is of strategic nature. You know, it's not one project or two projects, or it's not giving some money to centers of excellence. Developing centers of excellence which are capable of responding to national need is what is required. So I completely 100% agree with you. The funding has to be channeled towards developing capacity in the country and developing infrastructure. You know, young people like you, I mean, there is absolutely sheer wastage of your intellect if you don't really find institutional infrastructure. You know, our role is to educate, is to fight on your behalf and tell them that it is extremely important to invest in science and technology. It is important to develop infrastructure, institution, and link them with the industries also. Uh, but this needs to be a scientific priority. It needs to be a priority with political will. You know, Pakistan is unfortunately one of those countries which spend less than 0.3% of the total GDP on science and technology and less than 2% on education. So how can we expect that we would be able to compete with the world? How can we expect that these bold, bright, and beautiful young people would be able to contribute? That is the tragedy of the highest order. You know, if there is one single asset of this country, is young people. If we need to invest in one single thing, is young people. And that is what the message which we would like to give on every forum, PABIC or anything else. Okay. There is one there.
Assalamu
Alaikum salam.
Very nice lecture. Thank you very much. So the thing is, nowadays focus is mostly on digital media. So I think it's a suggestion if we can move to digital media like radio or television. So we have an example, Professor Dr. Parvez Khudbai. Uh, so he had a program, Kainat, on television, which made it very easy for a lot of people to understand what science is and how the universe works. How the universe works. So if we can move on to like a digital media, or we have a television or science channel in Pakistan, or radio broadcast that can make life easier for us. I believe that I think about myself as a scientist, we failed our nation in the same way as well because we didn't deliver as well. We have heroes like you, Dr. Rahman Saab. Uh, we didn't make our national heroes. Nobody knows. I mean, everybody in scientific community knows the name of Dr. Atar Rahman Saab, but nobody knows the masses that we have in the village doesn't know his name or his contribution. So if we can make them all our national, which they are, but we can spread their knowledge or introduce them to our masses, then people would understand and they would like to become a scientist as well, or they will have some knowledge about science as well. And I think that sorry if I'm speaking for too long, but the problem is most severe because God forbid if something a second COVID happens, we won't be able to survive that. Because if I ask somebody to wear mask and they won't wear mask because they don't know about virus or how it spreads, it's become a problem for future as well. So it's kind of suggestion. Thank you for your lecture.
And I fully agree with you that there are changing realities. Yeah, perhaps we need to go beyond print media. So print media is still very effective. We need to go to social media also. And you mentioned very rightly that we need to go to digital channels and all that. I invite you to visit Comstech website, and you will find lots of very useful information. We're still a long way to go, but we are moving towards that. We would be developing our own digital channel for Comsec and for, of course, for PABIC also. Thank you. And I fully understand and appreciate the fact that if awareness and science doesn't really become part of the society's behavior, then a lot of mishap can happen. You know, polio is one single example. आप पूछ रहे थे? हाँ सर आपसे एक वहाँ पीछे से ना कई दफा से
My name is Aslam Yusuf. I am from private sector seed industry. Dr. Sabah, you have raised a very pertinent question of combating anti-science and making science popular among the society through media. I would say that another disservice is also being done by the fake science or the heap of science called material which is being produced at the moment at our universities and most of the research institutions. I'm sorry to say that most of that material does not come up to the level and standard of true science, which you are advocating. And that's one of the reasons that our population, most of the even educated people, have lost faith in genuineness of science within our society. I would say that we also need to correct our directions of producing or developing real science at our universities and at our research institutes. Thank you.
Thank you very much. I think you know, pseudoscience or fake science. You know, nations have to develop their own mechanism of accountability. For instance, this whole concept of plagiarism and checking it was introduced. Similarly, if anyone found to publish fake results, which I don't really believe that most of the science in universities are fake. Absolutely not. This is a propaganda of completely rubbish people who want to discourage young people. The fact is they're working extremely hard. Their science may not be as good as someone working in Harvard and Oxford, but they are faithful, they're completely honest, and they're publishing good science. Good science may not be breakthroughs or blockbuster, but majority of the science which is published in from Pakistani universities is honest science. So number one, that I don't really believe that most of it, you know, I have seen one video of someone saying 95% of the paper published from Pakistan are fake. What a crap, you know. दुनिया में आप अपने बच्चों को अगर आप इस लेवल पे डिस्करेज करेंगे कि आप 95% फेक हैं तो इससे ज़्यादा बड़ी डिस्करेजमेंट हो नहीं सकती. हाँ, of course there are some people and there are some people everywhere in the world, not only Pakistan, everywhere. You know, आपने cold fission का सुना है. cold fusion का सुना है. There are papers, research papers which were found to be fake in later months also. So in such things, there should be a mechanism of accountability. And we should have a national system. Higher education का काम ये है कि वो ये भी देखे कि कौन लोग काम करें, इनको encourage करें और जहाँ पे problems हैं उन्हें solve करें. मगर आप exception के basis पे सबको brand नहीं करते हैं. I don't really think it's fair. Sir, आप.
Thank you for a very interesting lecture. Lots of things to think about. I had a question, but I'll postpone it in view of the comment from the young man behind me. And the comment there is, how does our society, Pakistan in particular, project science and into its children, to its students, etc. Some years back, I did a study on the Pakistani textbooks, all the way from class, I think, 1 to class 12, just to look to see what kind of topics they have for Urdu and English and general studies, Pakistan studies, social studies, to highlight figures of science in the world, not just Pakistan. You'll be amazed to hear that there is no mention of anybody, any achievement, all the way from people who made vaccines or who made other kinds of antibiotics. Or so the point is that our society does not project scientific achievement, scientists, whether they're our own or the world. So how should people recognize?
Exactly, I fully agree. I think really we are running out of. We'd love to have more questions, but problem is that we would have Dr. Kausar Abdullah Malik coming online also, so discuss कर लेंगे इजाज़त के साथ. अगर आप इजाज़त दें तो बाद में discuss कर लेंगे. Sure.
Thank you so much, sir, for such a informative lecture. Our next speaker is Mr. Aleem Ahmed. He is a senior science journalist, chief editor and publisher Monthly Global Science, and former blog editor Express. Please welcome Mr. Aleem.
Yes.
Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Assalamu alaikum. Hello and welcome everyone here and on YouTube, internet as well. First of all, I'd like to apologize if I make some coughs during my presentation because I had some sore throat last night. Now, coming to the topic, my presentation is bridging the gap. Of course, it is about bridging the gap between scientists and journalists. And I have proposed, it's nothing new, I call it a two-pronged strategy to bring scientists and journalists together, closer. First of all, while I was listening to the presentations and seeing them, I decided to try something which was not originally included in my presentation. As a science journalist, most of the time people think that a science journalist just communicates science to the public, but they simply do not know what communicating science is all about. As a science journalist who is working in this field for the last 34 years or so, I realized that the responsibility of a science journalist is to inform, entertain, educate, and inspire. These are the four pillars to me for a science journalist if you really want to work sincerely and honestly and productively, result oriented manner. Now, let me ask you a question. All of those who present here, is everyone representing a media house or a publication house? Journalists, as per se? Now, as we are in this area, which is sort of VVIP zone of Islamabad, we have witnessed during almost all the day the coverage right in your neighborhood, Election Commission Pakistan. So the journalists from almost every media house of Pakistan pass from here, but most of the people don't even know about what comstech is. So is the case with Pakistan Academy of Sciences, which is right adjacent to the Election Commission of Pakistan. So we can see our media channels, our media, what we are prioritizing. But this is the problem, and solutions are always there. First of all, let me take you to the issue. The issue is very old, traditional one that we are facing for at least, as far as my experience is concerned, for the last 33 or so years. Scientists and journalists are operating in two different and isolated spheres. What does it mean? It means scientists seldom aware of journalism or journalists and public communication of science. Remember, communicating science, that is writing a research paper for the other researchers, is something different. While public communication of science is something different, but it is relevant with that subject. That is communicating science. When you communicate science to the other scientists in the form of a research paper or a review article or a commentary article written specifically for other scientists, it is something different from the public communication of science. On the other hand, if you look at the journalists, they really know about science, scientists, and public communication of science. So in Urdu, we can say that dono taraf hai aag barabar lagi hui. This is a fire we have on both sides. Scientists and journalists have a same problem to address, and that needs to be resolved. As a result, that scientists and journalists are operating in two different and isolated spheres. We have the situation, and unfortunately, with all the social media we have, with the growing quantum of electronic media, internet, and everything else we have in terms of technologically advanced things we have at hand, the situation is getting severe and severe. Media coverage of science in general remains infrequent, inaccurate, or superficial. As I'm working with the Express Media Group in their digital department, I'm working with express.pk. as a sub-editor now, and I have also served at that website as blog editor. So I have seen much closer the whole sphere of journalists, most of them political journalists, much closer, and the blogosphere as well. So most of the time, journalists, because they are not very much aware of science or not science literate, so the coverage of science remains infrequent, not regularly appearing, inaccurate. Journalists usually make mistakes in their reports, even short ones, and superficial. Most of the time, journalists do not explore at depth or try to explain their audience in a detail. So is the case. Most of the time, imported themes are highlighted in local media. This is an issue we have experiencing as long as the journalism exists, at least science journalism exists in Pakistan. And it is since early 50s, 1950s. Unfortunately, because media and journalists and scientists coordination is very, very weak, not just weak, very weak, in not only in Pakistan but also in other developing countries. So we have to take imported themes or research work being done in a country which is outside our area or some other country. You know what? Because as far as my experience and other some of my colleagues, we often observe that scientists from the developing countries do not like to respond to an email from a journalist. I don't know why. Perhaps they fear that something will go against them, or if they will reply, they will be put behind the bars. I have no idea why they do so. But in general, scientists from the developing world, including from Pakistan, do not like to respond an email from a journalist. On the other hand, this is my own experience. Whenever I have emailed a journalist from, for example, UK, USA, France, Britain, or any other developed country, or even China, it took less than 24 hours them to respond. Even if say that I did not work with this, I'm connecting you with someone else who is in a much better position to respond to. Even if they regret, they respond. So in such a scenario, in such a situation, we are forced to publish, whether we like it or not. Most of the news items uh, are from abroad, or we call them imported themes. Having served as a as an editor of two popular science magazines, Science Magazine and Science Digest, and then as a publisher and chief editor of Monthly Global Science for 18 years, 1998 to 2016 continuously. I have this next point before you. Popular science periodicals covering science with detail and depth for science lovers are rare and poor. We always talk about science coverage in a newspaper, in a news channel, and so on. But if you look at the world, have you ever heard of Discover magazine, Popular Science, Popular Mechanics, even Scientific American? All these periodicals or Cosmos magazines, these magazines are popular science magazines. They cover a science story, even if, be it a science news or a feature or a dossier. What these magazines do, they take a beat on science or a story on science, dig it deeper, try to avoid technicalities, and address those who are interested in science as compared to common people more. So popular science magazines or popular science periodicals are much rare. We call them rarity in a country like Pakistan. And if they exist, they are very, very poor. And that is why most of them are unable to survive longer. A science journalist still remains alien for most of the scientists and even journalists.
Actually, गर्म पानी मंगवाया।
जी सर, अगर मैं the word science journalist, how many of you have heard the word science journalist before I introduced you? How many of you have heard the word science journalist before? So you are the people of science. If you may not have heard about science journalist, it means you have some reason because you are involved in research. But unfortunately, even the journalists, the the people from my own class, they don't even know what a science journalist is and what a science journalist does and how science journalism works. This something, this remains something alien for them, not only for scientists, but also for journalists. Now I'm coming to the remedy because we have been discussing such problems and situations for a long time. As far as I'm in this field, I have seen people discussing problems again and again, again and again, and again and again. We have solutions. We have been discussing solutions here at Comstech and at, thank you, Jazakallah, and at Pakistan Science Foundation, at various workshops, seminars, symposia. We have been discussing remedies in the form of recommendations. First and foremost, journalism, writing, and public communication related courses for scientists and public relations staff of S&T, Science and Technology organizations, preferably short ones. Such courses are very much needed because communication, if you are able to do science, which is very much complicated as compared to the journalism, then rest assured, if you have some interest, you can learn public communication science, public communication of science in just 3 days practical workshop. That's what I can assure you. On the other hand, science, scientific method, scientific research related courses for journalists, thematically arranged, short, and easiest possible for journalists and non-scientists. As I have mentioned in my previous slide, you might have seen that journalists don't even know about science journalism. So we need to introduce them to science, scientific method, and how scientific research is done. I am fortunate enough that I learned science journalism from a person, late Azmat Ali Khan, who was the founder and pioneer of science journalism in Pakistan. And I think you also remember him. I learned from the generation who were the pioneers. And I know that these problems exist within the circles of journalists. journalists usually do not have basic education of science or background knowledge of science. So we need to teach them or make them understand about what science is, how science works, and how scientific research is done, and how it is authenticated. You might have know, almost all of you know about peer-reviewed research publications. So I learned about all these things back in late 80s and early 90s, and that cleared my way to become a science journalist. In fact, let me tell you, I did my master's in physics, MSc physics, back in 1994. I have no degree, no diploma, and no certificate of journalism. So by definition, you can call me a non-journalist, but I am working as a journalist for the last 34 years. Now, remedy, we are continuing with it. We need science journalist organizations, associations, and networks. Why? Because for better cooperation and coordination among science journalists, first we need to develop a class of journalists as science journalists. Then we need to network them so that they can collectively work better and can learn from each other and as well as from the scientists. In past, uh, different organizations have been maintaining directories of scientists. I have seen one published by Pakistan Science Foundation in late 1990s, but as everything has gone online, so what I think, we need to have a scientist database, an online list of scientists arranged according to their disciplines and expertise to help journalists working on a specific science story, news or feature and so on. What I mentioned here specifically is that arranged according to their disciplines or expertise. This is very important because common people, a commoner, for them, everyone is scientist who is wearing a lab coat like thing, or someone who is working in a scientific organization is a scientist. They do not know that Dr. N.M. Bhatt is a nanotechnologist, and they should ask if they have any question about nanotechnology, they should ask to N.M. Bhatt or someone with expertise like this. About agriculture, they should ask about someone who has expertise in agriculture, even if, especially if it comes to agricultural biotechnology. And then right person to ask is someone who is working with or working in the field of agricultural biotechnology. They can answer you the question. Most of the time, if our journalists have a story of science related story, they ask wrong question to the wrong person and get the wrong answer. So the coverage of science becomes inaccurate or sometimes totally wrong. I have witnessed this not only in Urdu language newspapers, but also in English language local news stuff. You may remember Aga Waqar Pathan, 2012, the person who claimed he can run a car on water. Unfortunately, the mainstream media involving the hot shot or the great science, great journalists of Pakistan was easily deceived by this man. Even politicians were deceived by him. You know why? Because our journalist had no idea what does it really mean, why this claim was false. Unfortunately, most of the time, people contacted Dr. Hudbhai and Dr. Ataur Rahman because media people think that Pakistan has only two scientists. One is Dr. Ataur Rahman and other is Parvez Amir Ali Hudbhai. Of course, they are scientists, but they should also ask such questions to the people who are related with, for example, engineering, those who can tell you about why water cannot be used as a fuel. At that time, we had global science. And in September 2012, we ran a full-length story with 21 pages and 6 features, debunking the whole story of Agha Waqar Pathan. And at the end, when Agha Waqar Pathan was caught in case of robbery, we were the only magazine who said that if he is a robber, dacoit, or not is another case. And his claim of running car from water is something different. So his claims must be evaluated scientifically, and scientists should give a verdict about that. We were the only periodical, only publication saying that. So we need to have science database for the right connections. In the Western countries, we see lots of science media centers. In fact, we should have science media centers. These are the resource centers for scientists and journalists where they can collaborate and help each other to develop better and effective science stories for the masses. It is important because journalist is a person who knows how to put forward a story with a human element so that it can inspire and engage a common man, common people. So, and a scientist knows how science really works and why it is important for the others. So, science media centers are sort of resource centers, both for scientists and journalists, where they can collaborate physically or through online. Anyway can be done, but there exist, at least in the Western countries, science media centers. And I think as far as Comtech is concerned, we should have some science media centers so that the coverage of science can be improved in our countries. Similarly, science boot camps. There is a fellowship in MIT which is called Knight Science Journalism Fellowship. In it, they usually do what they usually do. They have a number of science boot camps in which journalists are connected with scientists for a certain time period. For example, 1 day, 2 day, formal and non-formal both manner. So such boot camps create a better understanding of science for journalists, and scientists can also better understand how a journalist works and how they should communicate with a journalist so that he or she can make a good science story attractive for the public. Now, this is another approach. Website for science and technology or research and development related press releases, preferably having updates about recent, latest and ongoing institutional R&D research and development activities that include research papers, projects and meetings. In this regard, we have three huge models. One of them is Alpha Galileo. Second one is Eureka Alert. And third one is press.nature.com. These models we have where only registered journalists from around the world can get access to the embargoed releases. We should work on them. Similarly, we also need an online database for science journalists, a list of journalists covering science regularly. Just like scientists, we also need to have niche specific science journalists so that for example, we have environmental journalists. So if a scientist wants to cover his environment related research or climate related research to be covered, then he should contact a journalist who is already working in the field of environmental journalism or climate journalism. Now, something very quick. Funding, monetary support for science periodicals, websites, social media platforms to sustain, improve, and enhance the public communication of science, hence the public understanding of science. This issue Dr. Iqbal has already discussed. The remedy is without funding, without monetary support, no one can function in a way that he or she should. So monetary support is it's not an individual's demand, it's a collective urge, so we should consider it. Unfortunately, the programs to fund such projects in Pakistan have literally ceased, a number of them. So monetary support for individual science journalists, project specific funding, this is also what we need to think about. The goal, all these activities, all these suggestions, all these remedies, what is the purpose of proposing them? What we should get? We should have in our mind at least a science aware, rational, tolerant, enlightened and a progressive society, knowledge based, innovation driven economy and a responsible citizenship. Thank you very much. Dr. Sumit, you want to continue or should I?
We can have one or two quick questions
Yes.
if anybody wants.
Thank you. I am Dr. Shujaul Mulk from Plant Sciences, Qaid-e-Azam University. Actually, Dr. इकबाल साहब से भी more or less इसी तरह का सवाल था. मैं उर्दू में इसलिए पूछ रहा हूँ, दो कुछ इंटरनेशनल ऑडियंस भी होंगे कि हम पाकिस्तान में पॉपुलराइजेशन और कॉमन मासेस के कॉमन लैंग्वेज में अगर बात करते हैं तो मीडिया का बड़ा रोल है. तो क्वेश्चन भी है और सजेशन भी, लेकिन अगर आप मीडिया के लोग इसमें थोड़ा हेल्प आउट कर ले और अपने टारगेटेड कस्टमर जो है, क्योंकि आपका बिजनेस होता है, एंटरप्रेन्योरशिप है, कि जाके इदारों के सरबराहों से मिल के साइंस मैगज़ीन की बात करें और फिर हमारे स्टूडेंट जो है, हमारे इदारे उनको पाबंद बनाएं कि वो ख़ास साइंटिफिक मैगज़ीन उर्दू इंग्लिश के अपने हॉस्टल्स और उसके लिए ख़रीद के पढ़ना उनके लिए ज़रूरी होगा. तो मेरे ख्याल में इस तरह ये सिस्टम आगे जा सकता है. तो इस पे आप कमेंट करें या जो भी आपके पास है डेटा वगैरह. थैंक यू.
Because you have asked this question specifically about Pakistan, so I would like to respond it in Urdu language. ऐसा नहीं है कि ये प्रोग्राम हमारे यहाँ नहीं थे. पाकिस्तान साइंस फाउंडेशन का प्रोग्राम हुआ करता था. उन्होंने पैसे की कमी का कह के सन 2014 में अपना प्रोग्राम बंद कर दिया। ठीक है, अच्छा, जहाँ तक ताल्लुक़ है मुख्तलिफ NGOs का, ऑर्गेनाइजेशंस का, मैं ये कहता हूँ कि देखिए सस्टेन्ड सर्वाइवल के लिए ये बहुत ज़रूरी है कि आपके पास बायरशिप हो। इंटरनेट में अगर आप वेबसाइट बनाते हैं तो एडसेंस से जो आपको बिजनेस मिलता है, मैं उसे कहता हूँ वो मूंगफली से ज़्यादा कुछ नहीं होता, उससे आप अपना पेट नहीं भर सकते। आपको लामहला कुछ ना कुछ ऐसी फंडिंग, ऐसा पैसा आपको चाहिए होता है कि जो रेगुलर बेसिस पर आपको मिलता रहे, जिससे आपके पीरियोडिकल के, आपके पब्लिशिंग हाउस के अखराजात पूरे होते रहे। वो जो आपने इंस्टीट्यूशनल सपोर्ट वाली बात कही, हमारे यहाँ इंस्टीट्यूशनल सपोर्ट किसी ज़माने में हुआ करती थी, और मेरा ख्याल डॉक्टर साहब को याद भी होगा, एक ज़माना था, हम उसको कहते हैं बड़ा सुनहरा दौर था, बहुत अच्छे तरीके से काम होता था। लेकिन आहिस्ता आहिस्ता यूँ लगा कि जैसे कि सब चीज़ें ख़त्म कर दी गई। अब जब एक चीज़ बिल्कुल डेड हो गई तो मैं ये कहूँगा कि हम कोई ना कोई स्ट्रैटेजी वर्कआउट करके हम ये कर सकते हैं कि सबसे पहले कुछ फंडिंग की जाए, एक चीज़ निकले तो सही। देखिए, जब तक एक चीज़ निकलेगी नहीं, मुझे मालूम है कि ग्लोबल साइंस के बंद होने की वजह क्या रही है, और मैं इस वक्त अगर एक्सप्रेस मीडिया ग्रुप के लिए काम कर रहा हूँ तो वो कौन से हालात थे जिनकी वजह से मुझे यहाँ आना पड़ा। तो जाहिर बात है, वो जो आपने जो बात कही वो पोटेंशियल सोल्यूशन नहीं है, वो टेस्टेड सोल्यूशन है। Unfortunately, our organizations of science have delisted the public communication of science or public understanding of science out of their priority list. So is the case of popular media. There is a niche media which is called popular science periodical or popular science media, which is not being supported. तो ये solution exist करता था, लेकिन उसको नजरअंदाज कर दिया गया। और कोई सवाल? Any other question?
Assalamu alaikum. I am Abdul Malik from Qadir University. I am a research student. So, sir, your presentation was quite informative for me. I have question, sir, why we are not encouraging research students and even graduate students for to blogging and writing about the science. Why we are not providing them a platform? As you mentioned that remedies for providing the journalism approaches to science and scientists, and then the journalist to scientific knowledge. But I want to know, the question is why we are encouraging the research students so that they are we should welcome them. They are coming for their research to publish them, or even not publish, to write in, as Dr. Shijal mentioned. So this is my question.
Yes, there has to be, but remember, if you are writing for popular media, your style should be different.
We will have this question again.
We will ask this
next
question
speaker.
again because our next speaker need to leave for a meeting. So let me introduce our next speaker, Professor Dr. Kausar Abdullah Malik, a well-known name in the field of biotechnology in Pakistan, and he will deliver his talk on status of agri-biotechnology way forward. Sir, over to you.
Thank you. Can you all hear me?
Yes, sir.
Yes, sir, we can hear you.
Okay, thank you so much for inviting me, and I'm extremely thankful to Dr. Iqbal Chaudhry and Samar and all your colleagues for organizing this. I hope that Ola is also around, and I mean, this is an important topic, and I had recently compiled a booklet also on status of agriculture biotechnology in Pakistan, just to show that how much work has been done in Pakistan, and why all this is not being commercialized or being utilized by the farming community or the end users. You see, but that means since many are younger colleagues are here, I would like to go through this some chronology of biotechnology, of agricultural biotechnology, especially in the country. And let me share my slide if I can. Let me find out where it is.
Sir, in your front, there should be a green sign with share screen.
Okay, okay. I'm doing that. Yeah,
procedure ऐसा है
So you just click on share screen and you will see your slide. So you must double click on that slide.
फोल्डर नजर आएगा आपको
So we can see your slides. बस इसको full screen कर लीजिएगा.
okay. Can you all see my slide now?
Yes, we can.
Yeah, okay. So I just wanted to give you a chronology of development of biotechnology in the country. You know, I mean, we have been fortunate that it has been we were one of the very few who started this biotechnology in the country way back about 40 years back. And we also trace our origin from the starting of biotech, the modern biotechnology in 1981 when we had our first training course on molecular biology at NIAB, and it was conducted by the late Dr. Iqbal Bukhari and from Cold Spring Harbor, and Dr. Anwar Naseem from, he was working at NARC in Canada, you see. So that was the beginning of introducing modern biotechnology in the country. And it was the same time UNIDO, the United Nations Industrial Development Organization, launched a project to have an international center for genetic engineering and biotechnology, because at that time there was a lot of excitement about these possibilities of this new technology of biotechnology. So they had asked for all the countries to be the candidates to for hosting ICGEB, and Pakistan very enthusiastically offered its candidature for hosting ICGEB, and that was in 1984. A team from UNIDO came to visit Pakistan, and we had conducted their visit to all the main institutes in the country, including NIAB at that time, and in Punjab University also, and at Qaid-e-Azam University as well. So, and they had a very important meeting with the President of Pakistan, General Ziaul Haq was the president, and he very anxiously, I mean, asked them to, to host it in Pakistan, and he offered all facilities or whatever they wanted to be given. But somehow Pakistan was shortlisted for hosting this center, uh, and the countries shortlisted were Pakistan, Belgium, and Italy, I think, you know, and but India was not even shortlisted at that time, and but Indira Gandhi was very mad. She was the head of the state at that time, and a lot of diplomacy and politicking went about, and at last it was decided to host this international center at Italy, at Rieste, and part of it was to be given to India to have a satellite center in Delhi. You see, you know, at that time, Professor, Dr. Paneer Ahmed Khan, and was very active, but somehow we lost. At that time, we asked the government that if you are interested in hosting an international center, why don't you have a national center? And that was the basis of having the National Institute for Biotechnology, Genetic Engineering approved in principle by the President of Pakistan. And in order to have that, we encouraged development of Center for Advanced Molecular Biology to be stationed at Punjab University to develop the manpower for such an activity. So eventually, both these institutions have now developed and they have become the first-rate institutions working in biotechnology in the country. And then in actual support came in 1999 or 2000, I think, when we had the beating of the NCST. NCST is our National Commission on Science and Technology, and it was headed by at that time the Pervez Musharraf had already taken over, and Dr. Ataur Rahman was taken as an advisor initially, and there they declared biotechnology as one of the six priority areas of science and technology, you know. And then subsequently, if we established this National Commission on Biotechnology, and it was formed under the Ministry of Science and Technology. And that was the time when Dr. Ataur Rahman was very active, and he subsequently became the chairman of the Higher Education Commission. And with his support, a lot of scientific activity was initiated. We then, in 2003, had the School of Biological Sciences established in the Punjab University, which was headed by Professor Akhtar, FRS, who was the first Director General of this center, and he played a pivotal role in initiating and developing the manpower and developing the infrastructure. And subsequently, over the years now, we have nearly 50 different biotech departments established in the university. Every university in the country has some kind of activity going on related to biotechnology, you know. And in this, the HEC had played a very important role by providing equipment, infrastructure to all the universities, and also developing the manpower. I mean, we had thousands of students going abroad doing PhD in wealth deputed institutions, and majority of them have come back and are still coming back, and they are the people who are now spread over all over Pakistan in many of the universities. This was the purpose of my compiling this status report about agriculture biotechnology, because I knew that there is so much activity going on and we must document that for two purposes. One is that our colleagues should know what other colleagues are doing, you see, and it should help them to collaborate, you see. Secondly, we must emphasize to the government, to the regulators, to the policy makers that so much expertise is already available, you see, and they should simplify and facilitate its commercialization now, you see, and that is most important because majority of the work which is being done in the laboratory is still not being commercialized or still not has not, because of the one or the other hurdles uh, in the regulatory process, you see. Uh, that made this is just to recap of the same, that we had started in 181, and then we went to establish CEMB and then IPG and then different centers and biotech GM crops, and we were also able to have so many activities. And this is just to show you, I mean, it's an old slide. It still shows NWFP. I'm sorry, it's KPK. And also we have in Swat, in Gilgit, in Peshawar, in Abbottabad, everywhere, there are important centers now working very effectively. And this is the resource that we have. And if we can manage all this resource and to develop agriculture biotechnology, which is the most important, you see, because green revolution has been there, and that was the main technology in 1960s to allow us to develop high yielding varieties. That technology has tapered off, you see. Now we do need another technology to give a major boost to our agriculture, and that is happening all over the world, you see. As I said, that green revolution has exhausted its utility, and biotechnology is the new technology for agriculture, and this must be understood by all our policymakers, you see. And just to give you, I mean, my younger colleagues, they just in a very simplified manner, the excitement or the edge of that biotechnology has, you see, and that is that in case of genetic engineering, we have an unlimited gene pool, which may be derived from virus, bacteria, fungi, plants, animals, or synthetic genes, uh, as compared to the conventional land breeding, which has got a very limited gene pool in the form of a compatible cultivars or a compatible varieties, you see. So this is a big advantage that we can have access to the entire gene pool of the living kingdom, you see. And that's why there is an excitement and of about this technology, you see. Well, you see, we have to compare it or to have some idea of the global activities, you see, because biotech crops are, as I said earlier, that are globally adopted because of the enormous benefits to the environment, to health of humans and animals, and contributions to the improvement of socio-economic conditions of farmers and the general public. You see, for example, ET cotton is or ET is the most commonly known technology nowadays. You see, I mean, that is for reducing these the pesticide spray, and I'm sure everybody will agree that pesticides are the most hazardous agrochemical which we use, you see, and any reduction in pesticides is definitely an improvement in our environment and for our socio-economic conditions of the farmers, you see. The global economic gains contributed by biotech crops in the last 23 years, which is from 1996 to 2018, have amounted to US dollar 225 billion you achieve as economic benefits to more than 16 to 17 million farmers, 95% of whom come from developing countries, you see. So we have to look at the world, you see, where the world is going, you see, and where these technologies are being utilized, you see. This, I'm sure that Ola might have also shared you some of this information, that there are about 190 million hectares of biotech crop, and these are being grown in 29 countries and 17 billion farmers, you see. So this is the one of the fastest adopted crop technology in recent times. You see, so this is we must take advantage of all these technologies. You see, and this, just for your information, that all these crops are being cultivated in these different countries. Alfalfa, for example, and the major trait is this herbicide tolerance, and canola, and for phytase production, then cotton. Major is for herbicide tolerance, and then insect resistance. All these countries of Argentina, Australia, Brazil, Colombia, Costa Rica, South Africa, USA, India, Mexico, Paraguay. And for insect resistance, we have, when Pakistan has still not embarked on the herbicide tolerant cotton, but they have this insect resistant in the form of BT, and Pakistan is included among those countries. And in addition, maize is another. Sorry, maize is another important crop where a lot of uh, transgenic varieties have come about and have been commercialized in all these countries like Argentina, Brazil, Canada, Colombia, Cuba, Portugal, Spain, Czechoslovakia, Romania, Honduras, Paraguay, Philippines, South Africa, USA, Uruguay, Vietnam. I am taking these names just to demonstrate that the biotech agriculture, biotechnology is global, and all these countries are responsible countries, and they are all utilizing this technology. You see, and similarly, soya bean and all this sugar beet, eggplant has been very, I mean, it was in in the press as well, and that Bangladesh has taken I mean, the leap forward by approving eggplant, ET eggplant, to be released and commercialized in Bangladesh. You see, and India had been a lot of topsy-turvy about it, you see. Anyway, the popular and potato, papaya, apple, squash, so all these are edible things, you see, I mean, there was a tendency among some of the policy makers, non-technical policy makers, that we are not going to approve any edible, commodity, which is JM. You see, you can see, I mean, maize is the most edible commodity. You see, maize, potato, even wheat. I will show you others also. But anyway, this is an interesting, I had compiled it from all the database provided by ISAAA, that these are the approval of events for major biotech crops up to 2019. Event, uh, uh, if I may explain to my younger colleagues, that event is, I mean, all these approvals are for the event. Event is that the transformation, when it occurs, that is an event, you see, so you can have several events, and you have to select the best event which you want to take it further, you see. So these are all commercial events which have been approved by different countries for different crops like cotton, maize, potatoes. Potato is another very popular in Australia and Canada, and then soya bean is well, I mean, in every country you cannot have any non-GM soya bean available in the world, you see, So canola is also there. Even rice has been has been approved in Australia also, in Canada and in China, you see, So this is an important development, uh, that even China has approved rice, you see. And then sugarcane, you can also see some of the countries. So everything is developing, you see, based on your own needs. We have Vietnam, for example, have approved 14 different events of maize, you see, and also of soya bean, you see. So, and USA is obviously is way ahead of all of us, you see, you know. And in Pakistan, we have only cotton, which has been, and even maize has not gone into the field, you see, you know. I mean, the maize was, it was field trials were held under the all the biosafety guidelines, but when everything was done, some fine one with the fames of one secretary, it was decided no, there cannot be any commercialization because it is edible, you see, you know, as if, you know, all these countries who have been using this genetically modified maize for umpteen number of years, I mean, they are either out of their mind, or, you know, I don't understand the mechanics and the thinking of some of our bureaucrats, you see. Well, I mean, as this is also, as we have already talked about it, you know, I mean, internationally, it is being grown all over the world, 231 billion hectares of land from plowing and cultivation. If you save, I mean, it saves the from the climate change point of view also. I mean, you can reduce the gas house, the greenhouse gases, their emissions as well, you see, you know. Now, let me come to the developments of biotech crops in Pakistan, you see, you know, this is more important to us, you see, you know. And as you can see that in case of cotton also, we have several field trials, and, you know, and it has been, many of these varieties have already been commercialized, and but cotton is the only variety, only crop where some commercialization has occurred. But even there, one of our problem is our very, I mean, our seed industry is not up to the mark, and they do not have the capacity to maintain the quality of the BT cotton. In other words, the quality, the expression levels of the proteins which are required to make it insect resistance, that is not there, you see. So until unless a continuous monitoring is done, it may not serve the purpose. But we have other varieties also, and in case of wheat, we have very good varieties from dust, drought, and salt tolerance done at Tibji. I mean, these have gone much ahead, and they are in the process of commercialization. And we have at FCC, at my institute, we have developed biofortified wheat for increased iron and zinc bioavailability. The field trials are there, and now we are in the process of collecting enough amount of seed to do the large scale field trials, you see. And then we also have varieties for increased phosphorus use efficiency, and also for increased nitrogen use efficiency, you know. So these kind of things are, and also in rice, CEMB and IPCHIP both are involved in developing insect resistance and bacterial resistance using XA21 gene, you know, and so this is also an important. And in case of maize, there have been number of all these the MNCs. Now Monsanto has been taken over, and now it is Bayer, and Pioneer has been taken over, and it is now Corteva, and so all these companies are also taking their field trials, and that's why we say that we have to improve and simplify our regulatory to give I mean an equal space to the private sector and the public sector. Sugarcane also, chickpea as well, tobacco, potato, peanuts, brassica. I just want to highlight all these because the more details of all these are available in the booklet that I'm talking about, and just to just to show you, if I can show you, this is the booklet, and it is available online, it contains all the projects and activities that are going on in the country, along with their names of the PI, and their addresses, etc., etc. You see, anyway, and the profiles of all big institutes like ICCBS and their biotech activities, like IBG, which is also in Karachi, and then IBG, which is in Peshawar, and so on and so forth. All the important institutes are there. You see, So let me then. I think I should finish it off. Uh, Pakistani biotech institutes are active, as I've already told you. Now, these are some of the challenges that we face due to climate change, you see, and that is changes in water availability, increases in exposure to heat stress, changes in distribution of agricultural pests and diseases, greater leaching of nutrients from the soil during intense rains, greater soil erosion due to stronger wind and rainfall, more frequent wildfires in dry regions, and increased flooding. Many of these areas biotechnology can directly help, So we would, we keep on telling our researchers, that they should keep all these things in their mind while developing their proposals, you see. Now, I think in the end, I would like to share with you my ideas of reasons for slow adoption of biotech crops, you see. At the moment, cotton is the only crop which is commercialized formally, you see, to some extent so far, you see. So that we should understand. Need to review and strengthen biosafety regulations and tools. You see, we were, since I was actively involved in the development of this biosafety regulation, but that was 15 years back. We had done that in 2005. Now lots of new technologies have emerged, you see, like CRISPR-Cas, like talents, like ring finger, like all these technologies have developed, and transcription factors, you see, have a very important role to play, so we have to take these things into account, and then incorporate those in our biosafety guidelines, provide exemptions. You see, if the manipulation is not from any other source, it is you are manipulating the internal and the plant origin, then probably you don't have to have that kind of a biosafety. You see, so similar things are there, and therefore we had requested the federal government, the Ministry of Climate Change, as well, to review the whole biosafety guidelines and make them up to date and have them simplified, you see, so that you are facilitating the commercialization of the things, because we have invested very heavily on all these activities. You see, according to my estimate, even this NRPU, which is the main working horse, about 5 billion rupees have gone into it. So, the other important, my contention is that GMOs are a target of fake news. I think Aleem is also around. He should also know that, you see, that GMOs are a target of fake news, center of which is European Union, where a political party has an anti-GMO agenda. They spend huge sum of money on anti-GM propaganda, and this fake news influences some of our bureaucracy, who are obviously a big hurdle in its development. You see, because even the chairman of the NBC is the secretary of Ministry of Climate Change. If that secretary is somehow influenced by these non-technical, non-scientific emails or things like that, then it is definitely a big hurdle. You see, some official documents claim that Pakistan is a GMO-free country. You see, as if Pakistan is already a polio-free country, you see, I mean, I have not been able to find any basis of such statement, you see. There is no formal announcement from today onwards. We will not have, if that was the case, then we should shut down all the biotech institutions, you see. Anyway, there has been not a single case of any disease or fatality due to consuming GM food anywhere in the world, you see, So these are the facts which we have to continuously fight and create awareness among our policymakers, among our colleagues, among, all stakeholders, you see. So I hope that with all these small efforts, we can achieve our goals, you see. And then thank you all for your patient listening. And if the time allows, I am will be available to answer any questions if I can. Thank you.
Thank you so much, Dr. Kausar. Any question for Dr. Kausar? If no, sir, let me check the chat box quickly. There is a question.
Yes.
Yes. Why Pakistan is at the bottom of the list of countries having approvals? What are the obstacles or hurdles?
Well, I have already told you that, you see, that because our biosafety regulatory bodies are not well, they need a lot of capacity. For a long time, they didn't have any, even now, they don't have any technical personnel. And so we keep asking them to have at least an independent uh, biosafety commission or biosafety cell so that they can work independently. You see, all the regulatory bodies have to be independent. You see, you just look at the RAP, you see, which regulates the pharmaceutical. I mean, that is a very strong and independent body, you see. Similarly, we ought to have a strong and technically sound, you see. You have to have, this is whole a technical issue, you see. I don't know if I'm able to answer.
Thank you, sir. There is another question from a participant from Africa. He said, how can we motivate government, politicians, and journalists to accept a member of scientific community to contribute to some of the decision concerning the biotechnology in Africa countries? Any suggestion for him?
Well, it's an uphill task, you see. We have to continue creating awareness, talking to our civil society also, talking to the relevant stakeholders, and that's the only way. But I think the things that I have said are absolutely true. This is all because internationally there is I mean, from European Union, all this emanates, and it is most interesting that even in European Union, the scientific community is up against all these people. You see, so. So, I mean, it's only my conviction is that it's only a matter of time if we keep on keep on our campaign for awareness and for because as I had the last slide showing that the saying no to GMOs is a crime against humanity. You see, So this is extremely important that we, the scientists and the people who are aware of all this, should keep on our campaign. You see. Thank you.
So thank you so much, sir. Yes, please.
Dr. Saab, thank you so much. My question is about the eutrophication, because these biotech crops need a lot of fertilizers, and sometimes sedimentation, mineralization, and eutrophication takes place in the soil. So do you have any plan for the alternate crops of GMO nature or any other local crops to mitigate the problem? Thank you so much.
Yes. Okay. You see, one thing that I do not think that the biotech crops use excessive fertilizers, you see. This is one thing. Secondly, that even biotechnology can develop crops with the reduced fertilizer. Fertilizer use. You see, we have, for example, we have already developed wheat variety with an increased fertilizer use efficiency. You know, because in all under even optimum agronomic conditions, you know, you can only take up 30 to 40% of fertilizer nitrogen, you see, you know. So all other thing goes either volatilized uh, or is converted to nitrates and then forms the one you said about eutrophication. That is under a normal conditions, you see, you know. So I don't think that biotech crops need any extra fertilizer. But on the other hand, the biotech crops can be developed for having an increased fertilizer use efficiency so that less nitrogen is applied, you see.
Thank you so much, sir. Alim sir, we will take your last question. Continue.
Uh, uh, can I also say something to Alim Saab? You see, I'm his old admirer. You see, you know, I mean, you see, but I mean, he was talking about science communication. You see, I mean, the one of the important thing is that until and unless our TV channels and our print media do not have dedicated science journalists, you see, or people who are responsible for scientific reporting. I mean, no, you can't have, you can't ask Pakistan Science Foundation or public sector organization to have areas of public communication. This is okay, that they should have that, but this is the prime job of the print and electronic media to have people in that area. If they can have a journalist for a crime journalist, you see, or a political journalist, why can't they have a science journalist, you see? So that is the thing that you should emphasize to all of them. Thank you.
Alim sir, आपने आपका-
So what the question was for me?
Question was that why print and electronic media have good journalists who cover science?
First of all, the reason behind is that we do not have good science journalists and journalists who are really able to cover science. Because first, we do not have good journalism in Pakistan. At the institutes and departments where journalism is being taught, too little emphasis, too little attention is paid to the quality. Most of the time, we produce crime reporters, political commentators, showbiz journalists, because these and even economics related journalists, because such niches or such disciplines have wider audience. This is what the media managers at the almost all the organizations, media organizations in Pakistan think. And because they think so, so the departments are also focusing on the people who are who has nothing to do with science. And that is why when a person who is already covering showbiz, politics or economics, when he or she goes to cover science, most of the time he or she makes mistakes. Mistake is a small word. I think I should say he or she commits blunders while covering science. So first, we need to improve the quality of journalism overall with more responsible journalism. First. Second, as I have mentioned in my slides, that we should have scientists and journalists to be educated. One, scientists should be made aware of how to communicate science to the public, while the journalists should be taught about how to cover science without inaccuracies and mistakes and without losing the public interest. This is exactly what I want to say. And fortunately, you will be definitely glad to learn that it was 2019 April when scientists first, it was the first time when they released a shadow of supermassive black hole. It was a very hot popular news. So because it was already my field, I have studied relativity and cosmology when I was in MSc physics. So I decided to make something new for Express News website, express.pk. I took a donut in my hand, got to the canteen, cafeteria, took the person with a mobile camera in his hand and started my script, explaining that, taking donut in my hand, and then started explaining what a supermassive black hole is, and what a black hole is, and what scientists are going to see or going to claim or going to tell you about these their new discovery or what they have observed. You know what? Impressively, that video, when it went on Facebook, it was, I think, 9th or 10th April 2019. Within days, it took more than 100,000 views, which was an amazing thing for even the people who are at Express Media Group. So I think uh, a trained journalist is really, really need what we need. So anything else?
Now it's the time for a launch of ISAAA. Ali, sir, please join me. Ola is with us from ISAAA. Dr. Kausar is with us. And thank you so much for your participation. And lunch is ready outside for you. Thank you so much.
Good job. Congratulations.